Hello and welcome to SudoKanard. We're here to solve this puzzle which has the title 50. It's a puzzle that I created recently to celebrate the birthday of my good friend Clown Hippo. And this variant is, well, it's a combination of two variants. This puzzle uses two mathematical variants. One of them is TomTom. So those cages, which look a lot like killer cages but are not, are TomTom cages. So it means that when you apply some operation to all digits in the cage, the result must be the number in the top left of the corner, in the top left corner of the cage, which is often 50, but not necessarily. It could be 1972 or 2022. And the digits are allowed to repeat. Well, anyway, there are 10 cells in this cage, so they have to repeat according to the general rules of Sudoku, of course. So the operation could be multiplication, addition, subtraction, or division, but actually you can guess that this will be a sum, and you can guess that this will be a product. Well, it's a little more tricky. Here you can guess that it's a product, and here it will be a sum, of course. So that's for the TomTom part. Then there's the Parity party, which is a variant that was invented by Glam Hippo, and it concerns the numbers you see outside the grid. So 16 is the sum of the first few digits, but how many digits? Well, this is what you need to find. But what you must understand is that you sum until you meet the first occurrence of some parity. I just write an example. For example, you could have, let's say, 3, 7, and 6. That would work. That's the sum of 16, and we stop when we meet the first even digit in this case. And then this 23 could be 6, 8, and 9. That's a sum of 23. And we stop when we meet the first odd digit. Well, actually, in the case of this very puzzle, this 22 could not be achieved with such a beginning on the other end. But to just illustrate what this means, that's a possibility. And actually, this 23 could also be something like, let's say, 1, 5, 9, and 8. So we stop when we meet the first even digit in this case. And this 8 could be 1, 3, 4. So we stop when we meet the first even digit. It could also be 8. We stop when we meet the first even digit. So whether we stop at the first even digit or the first odd digit is part of the solving experience. So let's begin. There's a very precise place to begin. This 50 clue can only be achieved with a product, and the product will be 5 times 5 times 2, but we need 4 digits, so the fourth digit will be a 1. So those are from 1 to 5, and both 5s are on some of the diagonals, and we get a 1 and a 2 on the other diagonal. Then there's something we need to understand about even sums, even parity party sums. And this fact is that we must necessarily have odd digits at the beginning and then an even digit. Because if you start with even digits and then you meet an odd digit, then your sum will be odd. So that won't work with an even total. So this will apply to almost all of the sums I've chosen. So now the question is, how many odd digits before the first even digit? And there again, there is something to be deduced. If you try to put an odd number of odd digits than an even digit, you'll end up with a sum that is odd, which doesn't work. So the number of odd digits must be even before you meet the first even digits. And for this sum of 22, you can see that 2 odd digits won't be enough, because if you only put 2 odd digits then an even digit, that will be 2, and your 2 odd digits should have a sum of 20, which doesn't work. So you must have 4 odd digits before having the first even digit, which means that 2 must be excluded from those. So we have 1 and 5 here, and 2 and 5 there. So that's 4 odd digits, then the first even digit. I could use coloring for that, but let's say it doesn't matter. And then that's 6, and those 2 odd digits that are from 3, 7, 9, together with this, must have a sum of 16. So you see that 7 and 9 will be too much here. We need the 3. So that's 3, 7, and then a 6. Or that's 3, 9, and then a 4. So this is actually 4 or 6. And then you see that this can only be with... Before coming to that, I must address a point, which is that the sum of all digits on the row is 45. So 22, 23, they sum to 45, which means that this party includes exactly those 4 digits, and this party must include the remaining 4 digits, which are 3 evens and an odd digit. So the odd digit must be at the end, and this odd digit is 7 or 9, according to what happens here. And those digits must include a 2 and an 8, and the missing digit is the one that is not in this cell. So I just note this like this, and we know there's a 2 and a 4 in them. Now there's something similar with this 28, which is that with 2 odd digits and an even digit, the maximum you can have is 24. So that's not enough. We need another 2 odd digits, and this is the even digit that happens next. But there, so those are odd digits. What is the maximum? The maximum is 24, which means that the minimum here is 4, but it could also be, well, if I try the minimum, then that is a 16, and 16 just doesn't work, because then this would have to be a 12, so there has to be a 9 somewhere, but that's not the point for the time being. The point is that these cells sum to 28, and we know that the whole cage here sums to 50. So the remaining 7 cells here must sum to 22. And if you look closely, you'll see that 22 is the absolute minimum we can put into those cells, because the sum of digits from 1 to 6 is 21, and the minimum will be achieved with a 1 here, and digits from 1 to 6 here. Well, I'm tempted not to pencil mark all 6 digits into those cells. I just pencil mark the fact that the remaining 3 cells in the row are 7, 8, and 9. But now, we know that those 4 odd digits don't include the 1, so they must be 3, 5, 7, and 9, which sum to 24. So this has to be a 4 to complete to 28. And now we know that this here is a 6, not a 4. So that's 12. This must be a total of 10. So we remove the 9. And we now know that this here is a 9, that 6 is excluded from here. You can check that. This makes 23 indeed. And then let's move back to this 28. So we know that here we have the digits from 1 to 6, but those don't include the 1 and the 4. So they must be from 2, 3, 5, and 6. And you can see here we get a quadruple. 2, 5, 2, 3, 5, and 6 quadruple. So 3 and 5 can't be in this cell, and we get a 7, 8, 9 triple. That's not a 9. And we know that 3 and 5 are both in those 3 cells, which means that 5 can't appear here. So that's the 2, that's the 5, that's the 1, that's the 5. And then what? So, because of this 5, 5 is excluded from here. And 5 on this row is not among those digits. It can only be here. And those are 1 and 4. And I think that's it for the time being. Except for something. Yes, let's move to this part. This 5 is interesting because we know that in the 3x3 box, in the 3x3 block, the sum of all digits is 45. Remove the 5, we are left with 40. And we complete the cage with 2 digits adding up to 10. And those are not 1 and 9. Those are not 6 and 5, 6 and 4, sorry. So they are either 2, 8 or 3, 7. Oh, I thought those would be disambiguated at this point, but I was a bit optimistic, I guess. So this should happen later. Where is the next place to look? This row will be completed by 2, 6, and 8 here. And that's interesting because 8 is not there, and 8 is here on this row. And those digits include a 6, and the other digit is precisely this digit. So they are from 6, 7, 9. And here we have 1, 3, and 4. And this 8 will be achieved when we get to 4, and we get to 4 once we've added those 3 digits, and the change of parity occurs with the 4 at the end. So 2 odd digits, and we stop summing at the first occurrence of an even digit. Right, where do we look now? Is this 16? Not sure about that. Is this that? Oh, perhaps the 10. Yes, that's the 10. 10 is an even sum, so we must have a certain even amount of odd digits, then an even digit. We won't take 4 odd digits, then an even digit, because, well, it would never work because 5 digits sum up to at least 15, actually. 1 even digit won't make 10, so it will be 2 odd digits, then an even digit. And 3 digits summing to 10 without using the 1 must be 2, 3, and 5. So we begin with 3 and 5 and end with the 2. So that's the 6. So that's a total of 10. And this cage has a total of 19, and it will obviously be a sum. So those 2 digits sum to 9. And with 16, we have the same type of argument as this. 1 digit is too little, 5 digits will be too much because the sum of the lowest 4 odd digits is 16. So we can't have 4 odd digits plus an even digit. It will have to be 2 odd digits, then an even digit. And this here will be 6 or 8. Alright, so what are the options starting from now? There are 2 things to consider. One of them is that, well, this plus that must be 16. And the other stuff is that we have a 72 tom-tom cage, and obviously it will be a product. If we put the 8, then those must have a product of 9, which will be achieved by 1 and 9, except that 8 followed by 9 here will be too much for the 16 sum. So in this case, it's actually 1 here, a 9 there, and 8 with 1, that's 9. We complete with 7 here. And 2 here to get to 90. So that's the first option with 8 here. Now, what happens if we have a 6 here? Then those two must have a product of 12. So it won't be 6 times 2 because we already have the 6. There will be 3 and 4. And because of this 4, and because this must be odd, it will be 3 here, 4 there. With 6 and 3 here, this will also be a 7. So that's a real 7, and that's a real 2. So we are left with 2 options here, and those will have to be disambiguated at some point later. On this column, we have a 2, 6, 8 triple here. Those 3 digits are known. The remaining digits must be 1, 3, and 9, so there's absolutely a 9 here. Those must be from 1, 3, and 9. And as I mentioned, there has to be a 9 here. All right. Next place to look could be here. Now, 24 could work with 7, 9 here and an 8 there, except that this cell prevents this from happening because there would be no candidate left for this. So 3 digits won't be enough for this sum of 24. We need to have 4 odd digits followed by an even digit. So this can't be a 2, it has to be a 3. That's a 2. And then these 2 cells that sum to 10 will have to be 3 and 7. Which means that this here is a 9, so that's not a 9. There's no 9 in here, and no 7 in there. And that's not a 5. And I think that's it for this part. Here, the missing digits in the column are 4, 6, and 8. Here there are 1, 7, and 9. So that's not 7. And we can check that this is 24 indeed. So that's an 8, that's a 7. Up there, we need a 2 and a 5 here, a 4 and an 8 there. Right? So the next place to look should be this 50 cage. So with that many digits, it will obviously be a sum. We already have 28. So those 4 should sum to 22. So is this the right moment to do that? What is the maximum value? Or what is the minimum value more like? Not sure that's the right moment for that. Well, I say 22. If I try to put a 2 here, can these 3 sum to 20? Yes, with 3, 8, and 9. So 2 here is valid. What if it's not a 2? If it's not a 2, that's 14. And we need another 8, which may be achieved by 1 and 7. So that doesn't seem so useful. Oh, I see what I can do. Here, because of this 16, for the same reason as here, I must have two odd digits in here. And at this point, I'm not sure I can deduce what those digits are. But what I know is that 6 is not an odd digit. So 6 must appear somewhere here, which means that this is now an 8. And because of this 2, this here is a 4. And because of this 4, this here is a 9, which means that the only option for this 72 is with 1 and 8. So that's 16, that's 72, that's correct. So that's a 2, that's an 8, and that's a 6, and that's a 2. And because of this 9, that's a 7, that's a 9. And we can disambiguate the 50 cage, that's 24, 28. 34 with 15, that's 49. So this has to be a 1, and this has to be a 3. All right, so 1 is not in here. This column still needs 5, 6, and 3. 3 is not here, so 3 is here. That's a 5, 6 pair. Here we need 1 and 7, the total of 16, it is. And here those are 4, 5, and 6. Let's consider this huge cage with a total of 50, which can only be a sum there again. The digits that are known with precision are those and the 3. That's 12, 14, 17, 25, 31. So those 3 digits must have a sum of 19. And you can see that this is even, this is odd. We need an odd total, so this one must be even. That's, what did I do? I forgot the 4. Well, what was I saying? So this plus that must be 19. That's it. 3 here would not be enough. 3 plus 8 plus 6 is 17. So that has to be the 9. It resolves a few ambiguities here. So now it's a 9. This plus that must have a sum of 10. So that's a 6 here and a 4 there. Right, so this 6 and this 8 tell us that this is a 4. So there are 2 options here. Because this 20 could be a product with a 1 and a 5 here. Well, this 5 disambiguates their positions. But it could also be a sum if those sum to 16, which can be achieved by 7 and 9. So this still needs some disambiguation. Now, where is the next place to look? We've used almost all clues except this 11 and this 22. So 22 will be a sum, it won't be 2 times 11. And the question could be, how do we achieve 11? How many cells? Could it be 4 cells? 4 cells would mean 1, 2, 3, 5. 1, 2, 3, 5 would end with a 2 because we would have the odd digits first and the even digit at the end. But 2 is not here. So that's not 4 digits. Could it be 3 digits? 3 digits ending with an odd digit would mean that the first digits here are even. So 2 digits plus that. Well, with the 9, we would have 2 even digits and a sum plus 9 making 11, that doesn't work. With 7, 2 even digits, 2 plus 4 plus 7, that's 13. That's too much. With 5, that would seem to work with 2 and 4 in here, except that if we have 2 and 4 here, that's a sum of 6, and those two would sum to 16, which doesn't work because they would need to be 7 and 9. So 3 digits do not work, but that needs some thorough study. So it will be with 2 digits. So those 2 digits sum to 11, and you see that it will be an odd and an even, so we will really stop at the first change of parity. But the important fact is that those 2 digits also sum to 11 to have a total of 22. 6 here would put a 5 there, which would clash with this 5. So that's an 8 with a 3. That's a 6. And this 3 produces 5, 3, 4, and 5. Now this row still needs 1, 9, and 6. 1 here would need a 10 there, that doesn't work. 6 would need a 5, which doesn't work because of this 5. So this must be a 9 with a 2. And we now know that this is not with 7 and 9, so that's 5 and 1. That's the product. And 6 is here. Now we can do some disambiguation. So no 5 here, that's the 5. That's the 6, that's the 9. And because of those 6s and 9s, we know that we have 6 and 9 here, which results this way. This 3 also gives us this 7, this 3, this 7, and this 3. We need 7 and 9 on this row, there's a 9 here. Here we need 4 and 8. And up there that's 1 and 2. And we finish with a 4 and an 8. And happy birthday, Glam Hippo! So that's the puzzle I created, and I guess it's definitely on the challenging side of things. So I hope you like this puzzle. Thanks for watching this video. See you soon. SudoKanard.